Algebra 1. So the first skill we're going to cover in this short video is to multiply an outside term by a binomial or a trinomial inside the parentheses, and we're going to be using the distributive property. The distributive property is something you're already familiar with. It just means you can multiply the outside term by each of the terms inside the parentheses and thereby eliminate the parentheses, get rid of them. We know that's important because parentheses are at the very top of the list in order of operations. So you can't really go anywhere until you get rid of the parentheses. And so we're going to practice that in a couple of different problems. And we're going to add to that the skill we've been working on the last couple weeks, which is multiplying expressions that contain variables and exponents. So quick review, remember when you're multiplying those types of expressions, first you multiply the coefficients, then you look for like bases and add their exponents. Let's put that up here in the corner. Look for like bases, and where you have like bases, you add their exponents. And remember, if a variable doesn't have an exponent, it's just a poor lonely variable all by itself, it always has an exponent value of 1. So sometimes you might go through the problem before you even start and give those variables with no exponent a value of 1. So you can remember to count that as 1 when you're adding. All right, so I'm going to go through both of these problems, one right after another, so that you can follow along and you'll be able to do your homework that is similar. All right, so first things first, I'm going to draw my little arrows to show that I'm going to multiply the outside term by each term on the inside. And then I'll go with my two-step process. First, multiply the coefficients. Look for like bases, add their exponents. Multiply the coefficients. Look for like bases, add their exponents. Again, multiply the coefficients. And then, even though there's no variable term here, the variable from the first term still finds its way into the product exactly as it appeared. There's nothing to combine it with, so it just kind of moves down into the product unchanged. All right, then I look at that product. I double check to see if there are any like terms that I could combine and further simplify the problem, but there's not, because notice these are all unlike terms because even though they all contain y, they're to a different degree. So this one, final answer. I'm done. I've got it simplified as far as it will go. All right, now this one, number 2, is just a little bit more involved. We'll need to use the distributive property a couple of times. Here in the first parentheses, and here with the second parentheses. And I also have a sneaky suspicion that there will be some like terms at the end that we can combine. So I'm going to go through and multiply. I'm not going to talk quite so much on this one. You can just follow along. So first one, second one, the third one. All right, I'm going to move on to this next one. First pair, oops, and second pair. Okay, so I've done all the multiplication and thereby eliminated the parentheses. I'm going to go through and just see if there are any like terms I can combine. Like terms, of course, means you have the same variable to the same degree. So let's look at this first term, 6t squared. Are there any other that also contain a t squared? And as we travel through, yes, indeed. So we will add their coefficients. And remember, when you're just simply adding or subtracting, the only thing that changes is the coefficient. The variable with the exponent just skates through the problem unchanged. It's very gentle on the variables. All right, so that's done. That's combined. And then let's look at our next set of like terms, negative 12t and positive 12t. Well, we have a positive and a negative of the exact same coefficient, and so that's going to cancel out to nothing. So it'll just kind of disappear from the problem and make our life easy. And then all we're left with is negative 45. There aren't any other whole numbers to combine it with, so it just ends up in the answer